So I think we discussed this one too, right?
Mm-hmm.
Let us do the third one. So third one says that to find a formula for the all points on the hyperbola, right?
Okay.
So the hyperbola equation you know, right?
Yes, I think I remember.
Yes, that is x square minus y square equal to 1. So here they are focusing on this hyperbola only. Formula
Mm-hmm.
for all points on the hyperbola. So that has rational coordinates. So whose coordinates are rational numbers. Right. So I think more or less the same idea, right? So you have to find a rational solution to the equation, and then take a rational slope, and then solve the thing, right? So what will be a
Okay.
particular solution to this equation? We have to find one solution first, right? What will be a solution?
Would be well, you can do x minus y, x
Okay.
plus y, right?
X minus.
Yeah, I mean, isn't that x squared minus y squared is not equal to x minus
Ye-
y?
Yes, yes, that is fine. That we can do. Means I am saying that just let us find one point, one solution to this equation. Then we'll use those things. So, for example, what I'm saying is, so if you remember, mm so in this case, we did that this 1 comma 1 is a solution, right? We first found that 1 comma 1 is a solution of x square plus y square equals to 2, and then solved for the
Mm-hmm.
rest. So that this
Yeah.
one solution I want to find out for this equation. So what will be a solution to this equation? Any solution
Mm,
by seeing? Can you see? Can you guess?
let me see. And it should be rational number, right?
Yes, yes, rational number. Yes.
I don't know. Rational number.
So one solution can be minus 1 comma 0, right? Minus 1 comma 0 is a solution, right?
Minus 1,0. Yep. Yeah,
Right.
I think it works.
So minus 1 comma 0 is a solution. So we'll consider the line that is a line through this point. So let L be the line.
Yeah, but I mean, I just didn't think of that because 0 is not a rational number, or is it a rational number?
No, 0, we'll consider 0 as a rational number.
Okay.
Okay. So let L be the line through minus 1 comma 0 and have slope.
But minus 1 is also not a rational number, right?
No, no.
1.
So rational number, it is not only positive. You have negative numbers also, right? In rational number.
But it should be in the form of A over B,
Yes, yes.
and
So
A and B being different.
yes, no, no, not A and B different. So the thing is, the GCDs has to be 1. So let me write down. So the thing is P over Q, where Q is not equals to 0, and GCD of P comma Q, this has to be 1. So this is the definition.
Mm-hmm.
Right? P and Q are integers. So here it is 1 over 1, right? Minus 1 over 1, right?
Okay, so P and Q are 1. That's why you're choosing that one.
Yes, yes. No, minus 1 and 1.
Okay, I see.
Okay.
Yeah.
Right. So we consider the line L that is passing through this point minus 1 comma 0 and slope and the slope is m, right? So this h is the, let us denote h as this hyperbola. So what will be the equation of the line? This equation of the line L.
Okay, so let's see. I mean, the equation of the line generally would be ax plus b, right? So in
Right.
this
So you
case,
have to find that. So suppose y equals to ax plus b. So now this point should satisfy, right? Not ax. So here slope we know mx, right? So it will be mx plus b because slope
mx,
we have
okay.
taken. So we have to find what is b. So minus 1 comma 0, this has to satisfy here, right? So what will happen?
So we need to find b.
Right.
Y minus mx, that would be b.
Right. So we have to put, so this passes through this minus 1 comma 0. So using that information, we can find b.
Okay, b would be m.
B will be, yes, b will be m, right? So it will be 0 equals to minus m plus b. B equals to m, right? So the equation of the line is actually y equals to m into x plus 1, right?
I see.
Okay, so now we'll put
Okay,
that
okay.
into the original equation, right? So,
Then we replace that.
right. Right. Now expanding, what you have?
N square case square was 1.
Right. So now if we expand, right.
Yes, minus n square equal 1.
Okay.
Uh-huh.
So now taking the coefficients together.
X square 2n square n square plus 1.
Right. So now we know that x equals to minus 1 is a solution, right? So this is a
X
quadratic equation.
equal to minus 1, it is a solution, yeah.
Right. So x equals to minus 1 is a solution. So this implies that x plus 1 is a factor, right?
X plus 1 would be a factor y.
Yes, because the roots are alpha beta, then we can factor right x minus alpha and x minus beta, right? Quadratic equation.
So you're saying you can factorize that expression, you can
Right. We
factorize
can,
it,
yes, we can factorize this quadratic equation, right?
and then you would find, okay, I don't know, well,
Okay.
yeah, sure.
So, right.
Yeah, I mean, yeah, x minus 1, okay, x plus 1, right. Yeah, I understand, because x is equal to minus 1, so
Yes.
one factor will be x plus 1. Okay, I
Right.
got that part, right. Yep.
Right. So the thing is, we have to find another root, right? So how to do that? Okay.
I
So
mean, we need to divide.
yes, that we have to do, but we can do like this also. Let us see. So let me write down this here. Right. So this middle term, this 2m square, what we can write is using 1 minus m square and minus m square plus 1, right? So what I can do is, it is 1 minus m square minus m square plus 1, right?
Let's see.
This minus of 2m square, this position.
Wait. So we are We're factorizing x plus 1, right?
Yes, yes. So I have shown you one method. So here I'm showing you another method. The thing is,
Okay, okay.
I will use the coefficients of x square and the constant term to find to express this coefficient of x in the terms of those two things. So if I take the coefficient of 1 minus m square and minus
Mhm.
m square plus 1, so if I write this, so then if you open up, this 1 and this 1 will get cancelled, right?
Okay, so yes, inside that bracket you have minus 2n squared.
Right. So
Right.
I can replace this minus 2m square using these two things, right? This whole
Yes,
expression.
yes. Yeah, I
Right.
got it. I got it. Yes.
So if I do that, you can see what will happen. So 1 minus m square x square plus 1 minus m square x minus m square plus 1x
X
minus this thing,
and
right?
1. Yep.
So from the first term, I can take 1 minus m square x common and get x plus 1. And from the second
X
term, I can take minus m square plus 1 common and then x plus 1.
X plus 1. Right. Okay. That looks more clear.
Yes. So now if I take x plus 1 whole thing, then I have x into 1 minus m square minus m square plus 1. Right. So
Mhm.
this part gives me the second root, right? So what will be the
That
second
would
root?
be the second. The second root would be x equal to n squared plus 1
Hmm.
over 1 minus n squared.
Right. So this is my second root, right?
Yeah.
Okay. So now we'll substitute back to that y equation to get the value of y. So y I know it is m into x plus 1.
X
So
plus
if we
1. Right.
substitute back, we have m into,
N squared plus 1. 1 plus 1.
yes, what will happen?
That would be, I mean, n squared is gone.
Right.
That would be 2n, 2 over n.
2m, right?
2,
This thing,
2m, 1, yeah.
right? So what we get is for every rational number n,
We didn't have to work using a over b because m already represents a rational number.
right? M is m. We are starting with a rational number only. Yes.
Okay.
So m is a rational number, and so for every rational number n, we get a point. The coordinates are x y is equals to, so x is m square plus 1 divided by 1 minus m square and 2m divided by 1 minus m square. So these two things with rational coordinates, that is on the hyperbola, right?
So, I mean, just to make this clear, so
Hmm.
that means that any rational number, which is a over b,
Right.
will be represented in those coordinates.
Yes. So the thing is, no. Let me explain what I'm doing. So the thing is, so we are trying to find all the coordinates that are rational number on this hyperbola, right?
Okay.
Right. So the thing is, so for any, we start with any m. So m, that is a rational number. Okay. So this I have told orally, but I have not written down. So m is a rational number. So we start
Mhm.
having, so we start m as any rational number, and I consider a line that passes through this point and slope m. Okay.
Okay, so we are doing the same as before. What we are doing is from one specific point,
Right.
which is 1 minus 1 comma 0.
Right.
We are, like drawing lines that
Right.
cross the graph, the hyperbola,
Right.
and then every time they cross, we can represent that as the coordinates we found below, no, the
Right.
answer.
Yes, that is the thing.
Okay. Only if that comes from the point minus 1 comma 0. Any other, intersection from other point that won't work.
Yes, that you can say. So the thing is, so we are considering. So yes, this is the particular thing we are considering. So if you go back here, okay. So the point is, if I fix one point, right? If I fix one point, I will take any rational slope and I can draw multiple lines like this, right? So
Right.
whatever rational slope I get, I can cover all the rational points on this circle, right?
Mm-hmm.
So that is similar thing we are doing. So here also we are considering the fixed point, one fixed point minus 1 comma 0 and considering a rational slope m. So we are trying to find out all the rational coordinates on the hyperbola x square minus y square equals to 1. So that is the idea.
Okay. So this is like a strategy to find all rational numbers in a easier way, because we can replace directly x comma y. We can replace different values for x comma y,
Right.
or it is easier to do it just with one variable, which is n.
Right. Okay.
I mean, which one? I mean, I'm saying why not the reason why we are doing this it is because it's easier to just have one variable m instead of having
Yes,
two
yes.
x
So the thing
and
is,
y.
instead the we have two variable function, right?
Right.
So our aim is to find all points on the hyperbola that are that whose coordinates are rational numbers. So this we want to find, right? So for that we are
Mm-hmm.
first reducing this two variable equation to a single variable. So single variable is we are expressing y in terms of mx.
Mm-hmm.
So that will help us reduce one variable. So here I have a quadratic equation where the coefficients is m and it is only in single variable x. So that
Mm-hmm.
help us to find out the coordinates with rational number. So that
Yeah.
is the process which we are following,
Okay. 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 I understand.
right? So
Yeah.
this is the coordinate how it looks like on a rational, right?
Yeah.
Okay. So what does it give is okay. So if I put back into the equation, then I have x square minus y square equals to 1, right?
Mm-hmm.
So if I put back, so this is done up to this one, the problem. So that is what you wanted to find out. So this whole square minus, so this whole square equals to 1, right?
Mm-hmm.
So from here I get m equals to 1 minus this whole square, right?
Yeah.
So if I send 2m square to the other side, so I have plus 2m square equals to m square m plus 1 whole square. So
Mm-hmm.
this give me a set of another Pythagorean triplets, right? So 1 minus m square, 2m, m square plus 1. So this is a Pythagorean triplet.
I see. So anything that everywhere where we have the form a squared plus b squared is equal to c squared, it's considered a Pythagorean triplet.
Right, right.
Okay.
So here actually, so you can, so actually it is not exactly Pythagorean triplet because m is a rational number, right? So we want integers. So you can sort of some generalized version you can say. So we have to more simplify. because here individually m they are rational numbers. So Pythagorean triplets is we are considering only integers. ABC, what you told, we are considering only integers. So in some generalized sense, I am saying that it is a Pythagorean triplet because it satisfies that form of equations.
Mm-hmm.
Okay,
Yeah.
so this is fine, right?
Okay. Interesting.
Right. So this was third one. So fourth one is, so next you have the curve. Y square equals to x cube plus 8, right? So they already have told you solutions. So it contains the point. The two rational solution they have given.
Mm-hmm.
1 comma minus 3 and minus 7 by 4 and 13 by 8. So they have already given that, right?
Yeah.
The line through these 2 points intersect the curve in exactly one another point.
Mm-hmm.
These 2 points. So that intersect the curve exactly at one other point. So you have to find that third point.
Okay. I see. So you can make a line, right, between these 2 points,
Okay.
and
So
you will
make a
have a
line
you will have
means
a.
how do you
I
want to
mean,
make
you
a line?
can. I mean, you can create like a formula for a line that crosses these 2 points.
Right, right. So given 2 points, you can find the equation of line. So how will you find that equation?
I think the slope would be x1 minus x2 divided by y1 minus y2. That would be the slope.
No, no, it is the opposite. Y2 minus
Okay,
y1. Hmm.
y over x. Okay.
Right. So let us compute that. So you have 2 points. So 13 by 8 minus of minus 3. So that will be plus 3. How much will be that?
24, 37 over 8.
Right, 37 over 8. And the other thing is minus 7 by 4 minus 1.
That would be minus 11 over 4.
Minus 11 over 4, right? So the slope will be,
That would be
so,
m, right?
right, that is minus 11 by 4. So it will be minus 37 by 22,
22. Okay.
right?
Yeah.
Right. So now how will you find the equation?
Now we can do y is equal to minus 37 over 22x plus b.
Right. So now you have to put one of the point. So you can use that
Yeah,
easier one. 1 and minus 3 you can use.
1 and minus 3.
So it's minus 3 equals to plus b.
Yeah, that would be,
Yes.
right, that would be 66. That would be 26,
29, right?
29.
Right. Equation of the line.
That would be y is equal to plus minus 29 or 22. Right, that would be the equation of that line.
Right. So this is our equation of the line, right?
Yeah, and now we need to just replace.
Right. We replace it there back. So the equation was x cube plus 8, right? Y square equals to x cube plus 8. So it is right. So we have to simplify. So it will be 37 square plus
2 times, yeah, 22 square plus 29 square, 22 square.
right. So can you simplify?
Mm-hmm. Um, I mean, how can we simplify this?
Just we have to multiply. Otherwise, we don't have any other thing. So the thing is,
Okay,
so we have 37. 37 square. How much it will be? It will be, I think, 1369. Right.
let me see. 37. Yeah, I think so.
It is 484. 22 square plus 2 times 37 times 29. How much will be that? Check.
2146.
Right. Mm, right. Plus 29 square will be, I think, 841. Right.
29 square. 841, right.
Right. So just to simplify, so we multiply by 484 on the other side. So and let us take everything on the other side. So 484 8 cube, sorry, x cube, then minus 1369 x square minus 2146 x. The constant term we have to simplify. So the simplification is 841 plus 8 into 484. So how much will be that? Sorry, this is minus
That will be
minus
8. Yeah,
this one.
let's see. Uh,
This one is
30, 31. Yeah.
right. So what we have is right. So now, so this is a cubic equation, right?
Mm-hmm.
So how many roots we have?
3.
Right. So among these three roots, actually we know two roots. We know the value of two roots. So what will be those
Oh,
values?
yeah, that is true. Yeah, that one root would be x minus x equal to 1.
Right. One is x equal to 1 and another is?
Y equal to, we have 4 roots already, right?
No, not four roots, two roots, right? Because uh, these are the things, right? So this is a solution. So one root is 1 and another root is minus 7 by 4. These two things we have.
Why only those two are the roots?
No, because we have only two solutions, right? Because the first coordinate only represent to x, right?
Oh, I see. Yeah, we have either x equal to 1 or we have either y equals to minus 3, but in this case, we only care about x.
Yes, yes. So here our equation is only depending upon x. So you have to take
But
the x values only.
those 2 points are not on the curve. I mean, those 2 points are anywhere else.
No, those 2 points are actually on this curve, right? So those 2 points are on this curve as well as those 2 points are on this line also, right?
Okay, so those 2 points are from the curve, right? Let's see.
Right, right. So
Yes,
both
yes,
of them.
contains
So
2 points.
Yes,
Right.
yes. So these 2 points lie on the curve, as well as we have found the line that joins these 2 points. So they are asking that they
Right.
intersect one more point on the curve. So we have to
Mm-hmm.
find that.
Yeah.
So total, the line passing through these points, these 2 points are actually intersecting at 3 points on the curve.
Yeah.
Right.
Yeah.
So
So
that's why we got a cubic equation.
yeah. So x minus one will be one root, and
Yes, one
x
factor, right?
that will be one factor, right? X
Mm,
minus one will be one factor, and the other factor would be x plus 7/4.
right. So x equals to 1 and x equals to minus 7/4, two roots of this equation. So hence x minus 1 and x plus 7/4, right, times x minus some alpha. We have to find out the third root, right? So this is
Yep.
actually equals to this maybe star we can give, right? So
Yep.
this
Yep. Yep.
factorization, right? So we have to find the third one. So how will we find the third one? So that is the thing. So the coefficients are actually big, so that's why there is a problem. So let me think. Okay, I think that is not a big deal. So you can use some calculator for now, because the coefficients are very big. It will take some time. Okay, so let me tell you the factorization here.
Mm-hmm.
So the factorization is like this. So 2146x. So this will be actually equal to x minus 1, x by 7 plus 4, and x minus 433 over 121. So this is a factorization. Okay.
Oh, I see. So you remove that outside. Okay.
Yes, because yes. So yes, you can verify later. So that will that is fine. So the third root is this thing, right? So the third point has x coordinate 433 by 121, right?
Mm-hmm.
So that will give me the y coordinate also, because we can we can find the y coordinate from the equation of the line, right? From this thing we can find out, right?
Yep.
So
Yes.
y equals to, I think, minus 37 by 22 and minus 29 by 22. Okay. Right.
Mm-hmm. Yeah.
Right. So this is, I think, 11 cube. Sorry, not 11 cube. I think it is 37 by 22. You have 22 is 11 into 2, and okay, so it will be 22 means 2 into 11 cube. So it will be minus in both of them. So you can take out minus. So 37 into 433 and plus 29 into 121 is how much will be that?
19,530.
Okay. Will it divide by 2 something? Will it uh, okay, let me check once calculator. So it is 37 into 433 plus 29 into 121. Yes. So it is 530, right? So we can cancel by 2, divide by 2 actually. So it will be 9765, right? Okay. So the
Yeah. Yep.
coordinate of the third point. So this will be 121 comma minus this by 1331 because 11 cube is 1331. Okay.
Yes.
So I think this is fine, right? You understood it?
Yeah. Yeah. I think this one is. I think this one was the easiest one.
Yes. More or less. Only the cubic thing it was different, right? Because we till only handle quadratic equations before this only, right? Because
Yes.
yes, that is fine because we know two roots. We have to find only the third root, right? Okay. So let us move to the fourth one. Sorry, fourth one we did. Fifth one. Okay.
Fifth one.
So it is saying first one. Every square triangular number can be described using the solution in positive integers to the equation. Okay. So square triangular numbers.
Square triangular numbers.
Yes. What is that?
So
So
what does that mean? Square and triangular at the same time?
so it is perfect square as well as it is a triangular number. So that's why it is saying square triangular numbers.
Okay.
So using
Okay, but
right solution in positive integers to the equation. X square minus 2y square equals to 1. So that you have to show. So first of all, okay. So triangular numbers, the form of triangular numbers, so Tn. So that is n into n plus 1 by 2, right? So this is the nth triangular
yeah.
number. And this is also a perfect square. So it is equals to some n square, right? Because it is also a perfect square, right?
Okay. So that's what it means. Okay.
Right. So from here, can we get something? So that is the idea. So can we? Yes, we have to find that it is the solution to this equation. So how should I find?
So this equation has roots. I mean, maybe we can start there. Like we
Yes, but it is a
could,
two variable equation, right? How will you do that?
but we could start by finding a solution to this equation,
Okay,
and these are positive integers.
right. So
So maybe we can find a solution for this equation.
okay, think about
That
it.
would be x. No, x3 and y2.
Yes, but I don't think that will help actually. So actually, they are not asking to find any solutions, right? So they are asking to verify that triangular square numbers are solution to this equation. So they are not actually trying to find the type of solutions or okay. So what we can do is like this. So from here, so what I get is 2n square, that is equals to n square plus n, right? Okay.
Okay.
Okay. So but if I want to complete this into a square, so complete square means so completing the square, right? So if I want to complete the square, then I have one n square term and one n, right? So there is a two ab term. The two is missing, right?
For to complete the square.
So I want to make it something whole square, then some constant term. So I want to complete the square, but here the two term is missing, right? Because this is a two ab term and this is the whole square term, right?
Okay.
So if I multiply by two on both sides, so it will be 4, 2 and 2, right?
Mm-hmm.
Then this one will no longer be a perfect square, right? Because 2n square is not a perfect square, right? So
Mm-hmm.
that's why I multiply by 4 on both sides. So if I multiply by 4, so I have 4n square and 4n, right?
Mm-hmm.
Now if I plus 1 and minus 1, then you can see that this part is a perfect square. So this is what I mean by completing the square,
Mm-hmm.
right? So what I have is 8n square equals to 2n
Two
plus
n plus
1
one
whole square
square.
minus 1, right?
Right.
Okay. So now if I okay, so if I send 1 to the other side and 8m I bring to this side, minus 8m square.
Right.
So this is nothing but 2n plus 1 whole square minus 2i's of 2m whole square, right? Because I can take inside 4, right?
Yeah.
So now you can see that actually, let me write down here. So 2n plus 1 whole square minus 2 into 2m square, that is equal to 1, right? So now if I look back to the equation, so if I consider this as my x and if I consider this as my y, then see it is matching our equation. What is given? X square minus 2y square equals to 1.
Sorry. Yeah. X a will be 2n plus 1 and y would be 2n. Yes, because um, we are like modeling, right? The first.
Right, right. Okay. So that is the idea. So the thing is, if I take x as my odd number, right? So the
X
question
will
they
be
are
an
asking
odd.
is that show that every square triangular numbers can be described using the solution to positive integers of this equation, right? So so if I take my x to be the odd number, right?
Hmm?
So that this triangular number, so let me write down. So this one is a square triangular number, right?
Yeah.
So the square triangular number has two. We can express it into two ways. One is it is a triangular number. That's why I have this form n into n plus 1 by 2, and it is a perfect square. That's why I have this form, right?
Yeah.
Right. So now if I take so if I take my x equals to this odd number, so 2n plus 1, right? So where this n is actually coming from this n, this n.
Sorry. Repeat that.
Yes. The thing is, so I want to prove that every square triangular number can be described using solution to this equation, right?
Yeah.
So any solution to this equation will be have two coordinates, right? One is x coordinate and one is y coordinate, right? Because it
Yeah.
is two variable thing, right?
Mm-hmm.
Okay. So now I start with any square triangular number. So since it is a square triangular number, I have two forms, right?
Yeah.
So one form is that it is n into n plus 1 by 2, and another form is it is m square for some m, right?
Yeah.
So I define x to be 2n plus 1, where this n is nothing but this n, the form of the triangular number.
But how do you know? How do you know that? I mean, how?
No, triangular number always I can find an n, right? So where it is of the form n into n plus 1 by 2. So that is the definition of a triangular number.
Yeah, yeah, I understand that part.
Yes.
But you
Uh,
said the n from the right is like the n from the left. You said something like that.
no, I do not get. Tell me.
Yeah, I mean, I agree with that. The blue one, I understand that part.
Okay.
Mm-hmm.
Right. So now, so I take my x to be 2n plus 1. So this is an odd number, right?
Yeah, that is an odd number, right? Yes, that is correct.
Right. And I take my y to be 2m. So what is this m? M is nothing from this m square. So this triangular number, since it is a square triangular number, I can there has to be an m such that t is equal to m square, right?
Let me see. Yeah. Okay.
Fine.
Yeah.
So if I take this as my this as my x and y, then I know that this is a solution. This is a solution to this equation because I have proved it that this x equals to 2n plus 1 and y equals to m. If I put that this is actually a solution to this equation, and also it is a triangular number because this equality is satisfied.
Okay.
So that's why the solution integer solutions to this equation, we can describe the square triangular numbers as integer solution to this equation. That is the proof.
I see.
Right.
Yep.
Right. So the last line, what we can conclude like that is so solutions to your x square minus 2y square equals to 1 with x odd and y even. So that will represent two square triangular numbers.
Okay. So after we equiparate square numbers to triangular numbers, I mean,
Right.
we can conclude that x is an odd number and y is an even number. That's the conclusion.
Yes, means yes. That is the conclusion. So if I want to find solutions to this equation, which corresponds to a square triangular number, so that forces x to be odd and y to be even. Other than that, the other solutions we cannot equate to a square triangular number. That is the thing.
So any, I mean, it's not going to be any x,
No, any x
any
and
y.
this equation x square minus 2y equals to 1. So this can have other solutions also, where x is not odd or y is not even. So that will not correspond to a triangular number. So that is the idea.
Mm-hmm. Okay, okay. All right.
Right. So the next point is, so what is saying that this curve x square minus 2y square equals to 1. So this
Mm-hmm.
includes the point 1 comma 0, right?
Yeah.
Right. So let L be the line that passes through 1 comma 0.
Mm-hmm.
Through 1 comma 0 having slope m. So we have to find the other point where the curve intersect.
Mm-hmm.
Yes. So what will be the equation of the line?
The equation of the line would be y is equal to mx minus 1.
Okay, let me check. So the equation will be, you're saying y equals to mx plus 1.
No, y is equal to m parenthesis x minus 1.
X minus 1, right? X minus 1, right?
Mm-hmm.
Yes, so if I put back into that equation, so it is x square minus 2y square equals to 1, right?
Yeah.
Right. So if we expand, what will happen?
X square minus 2n square, x square minus 2x plus 1. 2n square x square plus 4n square x minus 2n square.
Right.
Yeah.
So if we
Will
take
be
the coefficients together,
x square n square x 2n square plus 1.
right? So now this 4m square, what you can do is we can write it as 2m square plus 1 minus 1 minus 2m square, right? Using the two coefficients. So
Okay.
this is coming from here and this is coming from here, right? This two, right? So here
Uh-huh.
actually you can say that this and this becomes 4m square and this and 1 will cancel out, right?
Yeah.
So what you can do is 1 minus 2m squared x square. Okay, so we know that x minus 1 is a, right, x minus 1
Yeah,
is a,
x minus 1 is a solution.
right.
It's a factor.
Then if we take 2m square plus 1 common, then we have x minus 1. Yes, what will be the other solution?
X is equal to minus 2n square minus 1 over 1 minus 2m square.
Right, so you can take the minus inside. In the denominator, you can take it inside. So it will become,
2n square minus 1.
right. So the solution coordinate will be, so the other point will be, so, okay, sorry, we have to find the y also. So what is about y? So y will be m into x minus 1, right?
Yep. Minus
Yes,
1.
what will be that?
That would be n over 2n square minus 1.
Yes, so that thing will cancel out. Yes, so it will be, right.
Yeah.
Okay, so this thing is, so the x coordinate is 2m square plus 1.
2n square plus 1. 2n square minus 1. Comma.
Right.
Yeah.
Right. So you got more or less an idea, right? How to do it now. Yes.
Yeah.
Okay. So maybe we will stop here because it will take some time. Okay.
Okay.